Good morning. Let's go ahead and start lesson 5, factoring out by dividing out a GCF. So what is a GCF? It's what number goes into. Okay? Greatest number that goes into each of them. So if I look here at this first example, this is a way called factoring out. So when you see factoring, this is what you're going to have to do. So if I looked at 15 and 25, I should know that 5 goes into both. Well, when I look at both of these, I can also see that X goes into both. So really, 5X is going to be my GCF. So I'm going to take that out, and then I'm going to divide, just like we did on Monday. So 15x divided by 5x gives me 3. 25x squared divided by 5x gives me a positive 5x. And that's my answer. So it's the undistributive. So if I would now check my answer, so I could now do the rainbow, I would end up with 15x, 25x squared. And this is my final answer. Let's try the next one. I always start with the numbers. What goes to 3 and 12? Hopefully you said 3. Is there an X in both of these? Yes, there is. Is there a Y in both of these? Yes, there is. So my GCF is going to be 3XY. 3XY. And you know when we divide by both terms. So 3xy on the outside. And then I'm going to simplify this. The 3's cancel out. X squared, 2 x's on top, 1 on bottom. So one of them cancels out. And then my y's cancel out. So this is just that. Plus 12 divided by 3 is 4. X divided by X is nothing, or 1. Y squared divided by Y is just Y. So that would be my final answer. What goes into 12, 24, and 30? Well, the first thing I always think of is like 12. 12 does go into 24, but it does not go into 30. So what else goes into 12 that's big? I know 6 goes into 12. So 6 goes to here, it goes to here, and goes to here. So my GCF is going to be 6. Do they all have X's? Yes. Do they all have Y's? Yes. So I'm going to divide each one of these by 6xy. So my 6xy is on the outside because we divided it out. And then so now we have what's left? 12 divided by 6 is 2. X's and y's cancel out. 24 divided by 6 is a 4, so that's a positive 4. The x's cancel out. Y squared divided by y is just y. Negative 30 divided by 6 is a negative 5. I have an X, and then how many Y's do I have here? Hopefully you said 3. 4 minus 1, 2 minus 1. Or if you think about it, there's 2 on top, 1 on bottom. That means this one can cancel out 1, and you're left with 1 on top still. And then that's my final answer. Next one. What goes into 3, 15, and 27? So I say 3. 3 is correct. A's, they all have an A. This has b squared, this has b squared, this is b to the third. So actually they have two b's in common. Each one of those has at least two b's. So this is 3ab squared, 3ab squared, 3ab squared. So we're factoring him out. Anything divided by itself is just 1. This is the same thing. 15 divided by 3 is 5. I have 1a and no b's. The b's canceled out here. 27 divided by 3 is 9. The a cancels out, and then I'm left with 1b. Again, I can always check my work by distributing it, redistributing it. Next is called the zero product property. And I'm going to kind of ignore what this says and write my own rules here. So what this is saying is you're going to set each term to 0. So if you look here, I have two terms. I have x, and then I have x minus 2. They're both separate terms. So I'm going to set x equal to 0, and I'm going to take this other one, x minus 2 equals 0. And this one's already done. It's already solved for x. And then I'm going to solve for variable. One kicker here is you might have to factor first. And that's that GCF. In this case, there's nothing to factor, so we're going to continue. So to solve for x here, you know to add 2 to both sides. So x equals 2. So to be quite honest with you, what does this mean? This means as you have a graph, this is going to pass through 0, x is 0, and x is 2. So it might look something like this. So these are your zeros. Your zeros are where you intersect intersect the x-axes. We'll get into that a little more, but this is how you do it. This is how you solve these. So these are already set to 0, so I'm going to set them both equal to 0 separately. S minus 3 equals 0. 3s plus 6 equals 0. Solve for s. This one, I add 3 to both sides. S is equal to 3. This one, subtract 6 to both sides. 3s is equal to negative 6. Divide. S equals negative 2. So again, if I was looking at a graph, that means this is at a negative 2 on my x and a positive 3. So however that may look, those are your zeros. Where it's crossing that x-axis. That's what zeros mean. Here's where you have to find GCF first. Okay, so if you look here in your mind, you have to say, oh, 5 goes into both of these. Does x go into both? Yes. So I'm going to factor out that 5x. And when I do so, that leaves me with 1 minus, anything divided by itself is 1. This becomes 8x equals 0. Now I have my two terms. I'm going to say 5x equals 0. 1 minus 8x equals 0. Setting them both equal to 0. Solve for x. Use your calculators when you're dividing, even if it's by a 0. Sometimes that one's tricky. And I did get 0. This one I need to subtract 1 from both sides. So I'm left with a negative 8x equals negative 1. And then divide by negative 8. So x is equal to 1/8. And I'm going to just leave that as a fraction. That's fine. This one, first of all, it's not set equal to 0. So set to equal 0. So I'm going to subtract 20x from both sides. So I end up with 12x squared minus 20x equals 0. Now, do I have a GCF? Yes. What goes into both of these? Let's see. I know 12 does not go into 20. 6 doesn't go into negative 20. 4 and 3, 4 goes into both. So we'll do 4, 4, and they both have an x. So 4x on the outside, divide that, gives me 3x minus 5. Now we need to set these both equal to 0. Solve for x. Here's one solution. Divide by 3, and x equals 5/3. And that is okay to leave it into an improper fraction. Sorry, you couldn't see that. All right? All right. Hop to your lesson. If you have any questions, please reach out. That was 3 separate things, so kind of a big deal on this one. This one was a little more difficult than what you've had in the past few days.